Welcome back, everyone. In this video, we'll be continuing section 10.3 on parabolas. This time we'll be starting with an application problem. So the story goes like this. It says a reflector for a satellite dish is parabolic in cross-section, and the receiver is at the focus F. The reflector is 1 foot deep and 20 feet wide from rim to rim, as shown in the picture. Based on this, we want to know how far the receiver is from the vertex of the parabolic reflector. So we want the length marked off in the question mark. So where to start? Okay, if we want to find that length between the basically the vertex of the parabola and the focus, then it's going to be a big help if we have the equation for the parabola. And so let's start by doing that. So what we'll want to do is situate this parabola so that its vertex is at the origin. And then based on the picture, I'm going to make it so that it opens upward. I'm drawing this so that the curvature is more exaggerated, okay? That's just going to make it hopefully a little bit easier on us because this thing, the curvature is really slight. So vertex sitting here at the origin, and this thing opens upward. And so I know the equation will have to look like x squared equals 4py. And so if we knew the p, then we would be finished with getting the equation. Once we know the equation, we can figure out what it is that we are doing. So the thing is that what we need to know actually in the question is the distance between the vertex and the focus. That is, what the problem is truly asking us for is the p, right? That's what we need to know. So it's not even so much about finding the equation because we need the p to get the equation, but the question is actually asking us for p, the distance between the vertex and the focus. So how can we get that? Well, all we have now to really work with is the picture, the numbers in the picture, and the fact that the equation has to look like x squared equals 4py. So if the vertex is at the midpoint basically of this 20-foot segment, then that means if we consider this point, let's say this point on the parabola, then from the vertex that would be 10 feet to the right and 1 foot up. So this would have an x coordinate of 10 and a y coordinate of 1. That would be the end of where the reflector is. So that means that the point 10, 1 has to be on the parabola itself. So it should satisfy the equation. So 100 is equal to 4p, and so p has to be 25. So the distance is 25 feet. So this didn't take a lot of calculating, really. I mean, the equation solving part was super short. The work came in kind of analyzing the problem, making up a little sketch, and figuring out how to connect the information we have and the information that we don't have. Okay, so continuing on, we want to see about graphing a parabola that it's been shifted. Let me fix my notes real quick. All right, so that's better. So we've talked about shifted ellipses and hyperbolas before, and so this is the part where we'll look at shifting parabolas as well. So for the rest of this video, at least, there's no guarantee that the vertex on a parabola will be at the origin. It could, in fact, and is likely to be somewhere else. So just to kind of review about the facts about shifting, in our formulas, if we replace x by x minus h, that will result in a right shift. If we replace x by x plus h, that will result in a left shift by h units. If we adjust the y's, y replaced by y minus k will result in an upshift by k units. Y replaced by y plus k will result in a downshift by k units. So let's take a look at the formula we have here. For this one, it's to sketch the graph of x minus 4 squared equals negative 4, y minus 1. And so we want to think about what each of these shifts has done. So x minus 4 instead of just an x there, we have x minus 4. So that would be under item 1 here. That means that this, our regular, what we think of as a regular parabola, has been right shifted by 4 units. Okay. And then y, instead of y, we have a y minus 1. So taking a look under item 3 in our list, that means that it should be upshifted by 1 unit. Okay, so rather than having the vertex at 0, 0, that means that our vertex will be at 4, 1. Okay, so the approach that we can take to this is we can take and think about what the graph of the unshifted one would look like. That is, it would be x squared equals negative 4 y, right? And then just relocate that so that its vertex is in the correct place. Okay, the graph of x squared equals negative 4y, this one, the x is squared, so it's opening either up or down. And since its coefficient of y is negative, it's going to have to open downward. Okay, so the graph of x squared equals negative 4y would look roughly like that. Okay, but this one, though, is going to have its vertex at the point 4, 1. So we'll start working on that on our grid. So the vertex is at 4, 1. And then where would the focus be? So again, going back to our rough draft picture over here, the formula is x squared equals 4py, right? Okay, so then 4p is negative 4. So p is negative 1. So if our parabola had been situated so that its vertex was at the origin, the p would have been at negative 1. For this one, our actual parabola, the vertex is at the point 4, 1. And so its focus will be 1 unit below that. So the focus on ours is at 4, 0. The vertex was at 4, 1, which we already noted that. The focus is at 4, 0. So then our directrix will be on the opposite side. It will be horizontal. It will be y equals 2. Okay, it has to be 1 unit up from the vertex. Now the vertex is, of course, not at the origin. The vertex is at the point 4, 1, and so it will be 1 up from there and horizontal, so y equals 2. Okay, so then in order to produce a couple of points to help us draw our graph, again, let me go to our unshifted version shown to your right. Moving around too much. There we go. Okay, so we would need to come up with some points that we can use for this. So if we choose x to be 1, then let's see what that gives us. If x is 1, then y would have to be a fraction. And there's nothing wrong with fractions, although it's going to make my picture a little harder to deal with. So instead, let's make y be 1, or negative 1. If y is negative 1, then the right side will be positive 4, and so x will be plus or minus 2. So the points 2, 1, sorry, 2, negative 1, and negative 2, negative 1 would be on the graph of our parabola on the right. So we'll just do that relative to our new vertex. Our vertex is at 4, 1, so we'll go 2 units to the right and left of that, and then down by 1. Okay, so 2 units to the right and down 1, 2 units to the left and down 1. And so we can use that to help us draw in our parabola. Okay. All right, so that has been our first example of a shifted parabola. We'll do others. Along the way, we also found the focus and directrix. Our overall approach to doing this was figuring out what the unshifted parabola was going to have to look like, and then modifying whatever we get to give us our shifted version. Okay, well, we have more examples to come. All right, so let's see another example, and this one will be again grafting a shifted graphing a shifted parabola. And this one is not from our textbook, it's a different textbook. This will be number 19 of what you're seeing here. What's one thing that is interesting about this is that the parabola is not written in that kind of already standard form that we're used to, or getting used to working with, right? So what we're going to do is kind of like what we did with ellipses and hyperbolas, and complete the square to put it in the kind of correct form. So on this one, we see that we have a y squared term, a y not squared term, and then an x term. So I know that this should end up as y squared equals 4px. And so we're just going to have to rewrite this using completing the square. So the y stuff should be on the left and everything else should be on the right. So let me keep y squared minus 6y on the left side. And then the minus 12x plus 33, let me subtract that from the left side. So we'll have 12x minus 33 on the right side. Okay, so now we want to complete the square in y. So taking a look at the 6 in there, we'll take half of 6, that's 3. 3 squared is 9. So we'll be adding 9 to both sides. Okay, so now we will continue with the factoring on the left side. So we should have y minus 3 squared. And then on the right side, 12x, and then minus 24 on the right side. So we're getting there. So notice that the 12 and 24 both have 4 as a factor. So let me factor out that 4. So that will give us, actually, no, let's factor out the 12. 12, and then that will be x minus 2. Okay, so that's better. So we can read off the shifts from this. So this will be y minus 3. So that means that we should be up 3. X minus 2. So that means that it will be right 2. And then that 12 is our 4p. So p has to equal 3. Okay, so let me think about where the vertex will be. The vertex will be at 2, 3. Okay, so the vertex is at 2, 3. Starting to draw it. And then this thing is going to open which way? So let's try to think about the parabola without the shift in it. So that will be y squared equals 12x if it were sitting at the origin. So y squared is always positive, 12 is positive, so that means, well, x would have to be positive too. So this would have to open to the right. Okay, and so the focus here would have to be at 3, 0 if the vertex were sitting at the origin. So this thing will open to the right also, and its focus will be 3 units to the right of the vertex. And so that will be at 5, 3. Okay, so once again, we are thinking about where would our unshifted parabola have its important features like focus and directrix, and translating that to have a vertex, in this case, at the point 2, 3. Okay. And then we've determined that this thing has to open to the right. So for my untranslated one, that is y squared equals 12x, let me find just a couple of points and we can draw that on here. So we want to try to find values that will actually fit with y squared being a perfect square. So a perfect squares I can think of that would have 12 as a factor would be like 36 actually. So if I take x to be 3, then 12 times 3 is 36. And so y could be 6, right? Y could be 6, y could be negative 6. All right, so the points 3, 6 and 3, negative 6 would be on the graph of my not shifted parabola. So from the vertex of my shifted parabola, I will go right 3 and then up and down 6 to generate additional points. So to go right 3 would put us at 6. I can go down 6 pretty easily. Right 3 and down 6. Down 6 will put us at a y coordinate of -3. And then we've gone right 3, so that is from an x coordinate of 2 to an x coordinate of 5. Okay, so something like that. And then if I wanted to go up 6 from here, my grid doesn't go up that high, so we're going to fake it. It could look nicer, could look a lot nicer. Okay, all right, so that's decent. So that is our graph. We showed the focus, and we should also include the directrix. So where will the directrix be? So we saw that the focus was 3 units to the right of the vertex. So that means the directrix will have to be 3 units to the left of the vertex. So directrix. And it's vertical, so x equals. And if it's 3 units to the left of the point 2, 3, it'll have to be at x equals -1. Okay. That should be heavier in mine. All right, so there's our directrix at x equals -1. Okay, it's 3 units to the left of the vertex. The focus was 3 units to the right of the vertex. All right, so that takes care of that example. We have more to come. All right, so once again, we're going to be sketching a shifted parabola. We're going to find the vertex, the focus, and directrix of the parabola. So taking a look at the equation, we have y plus 1 squared equals 16, x minus 3. So the y plus 1 part means that it will be shifted down 1. And then the x minus 3 means that it should be right shifted by 3. Okay, so that means that our vertex will be at 3, -1. And then let me write the version of the equation that doesn't have those shifts in it. So that would be y squared equals 16x. Okay, so y squared is always positive, 16 is positive, so that means that x has to be positive. So if it's y squared, it's side opening, and if x is positive, that means it has to open to the right. So if this thing were centered at the origin, it would look basically like that. Okay, just right opening. Okay, and so this thing has as its vertex the point 3, -1. And so then we're going to want to figure out where the rest of the stuff is. So taking a look at our equation, we have y squared equals 16x. If that's going to be y squared equals 4px, that means 4p has to be 16. And so p has to equal 4. So the distance from the vertex to the focus is going to have to be 4. And since this thing opens to the right, the focus will have to be to the right of the vertex, 4 units away. So that will be at 7, -1. So the focus will be at 7, -1. Okay. And then along the way, let's go ahead and get the directrix while we're at it. So the directrix will have to be vertical. So it will be x equals. And if p is 4, that means that it'll have to be 4 units to the left of where the vertex is. So if the vertex has an x coordinate of 3, then that means the directrix will have an x coordinate of -1. Okay, so there's that. And so then once again, we get the focus, the directrix. We just need to get, again, a couple more points to figure out just exactly how curved this parabola is. So taking a look, we have y squared equals 16x. So again, taking the non-shifted version, we'll just adjust for where the vertex is now. If x is 1 and x is 1, the right side will be 16. So if y squared to be 16, y could be plus or minus 4. Okay, so the points 1 and then plus or minus 4 will be on the parabola. So from the vertex, I will go to the right by 1 and then up or down 4. Okay, so back to our picture. Let me go to the right by 1 and up 1, 2, 3, 4. To the right 1 and down 1, 2, 3, 4. Okay. All right, so there's our graph of our parabola. Okay, let me make sure I've done everything. We sketched the graph. We found the vertex. Can I write that here someplace? The vertex is at 3, -1. Okay, vertex, focus directrix. Okay, so we got it. Okay. All right, in the next one, example, we're finding the equation of the parabola. We're told where the vertex is and where the directrix will need to be. So for this one, it's going to be a good idea to actually make a rough sketch of the parabola. That'll help us produce the equation. Okay, so we know where the vertex is supposed to be. It's supposed to be at -3, 5. Okay, that's where the vertex is. And that's not a lot to go by. So we have to think about what else do we have, which is the directrix. The directrix is y equals 2, and that's horizontal and below the vertex, right? That's y equals 2. If it's horizontal and below the vertex, then that means that the parabola has to open upward. Parabola always opens away from wherever the directrix is. Okay, so that means that it'll have to be x squared, right? X squared equals 4py. Okay, so just to recap, how did we get this far at least? We were given where the vertex is. That's at -3, 5, so I drew the -3, 5 on there. That was just a dot. And then we knew where the directrix is. We were given that also. It's y equals 2, which is below the vertex. The parabola will always open away from wherever the directrix is. So if the directrix is horizontal, the parabola has to be either up or down opening. Since the directrix is below the vertex, it has to open up. So that's how I got the little curve. Since I know that it opens up, it has to be x squared equals 4py. Okay, so we need to adjust for where the center is and also figure out what the p is going to have to be. So let me go ahead and figure out the p part first. So the p part, actually let's put in the center part first. So it was left shifted by 3, right? So the vertex is at -3, 5. That's a left shifted 3. So that would have to be x plus 3 squared for the left shifted 3. And then 4p, and then for y, it was upshifted by 5. That'll have to be y minus 5. Okay, so then all we have to do is figure out the p. So to get the p, we need to know how far is it from the vertex to the directrix. Okay, that's what p is. So the y coordinate here, the y coordinate of the vertex is at 5, and the y coordinate for the directrix is 2. So how far is it from 2 to 5? It's a distance of 3. So that distance has to be our p. Okay, so then that gives us altogether our equation, x plus 3 squared equals 12, y minus 5. Okay, so the sketch here definitely helped us produce the equation, but we got that. Okay, all right, so what's coming next is we have some more examples. That basically does it for most of our parabola work, but we do have some more examples of parabolas as well as some other conic sections. So that's coming next. So it turns out that the general equation for any shifted conic looks like this. Ax squared plus cy squared plus dx plus ey equals f, where the a, c, d, e, and f are all constants. So depending on what those are, determine the a and c especially, that dictates what kind of shape we have. If both a and c are non-zero, then we get either, let me re-say that. If a and c are both positive, then we get either a circle or an ellipse. If they're equal to each other, we get a circle. If a and c are opposite signs, we get a hyperbola. A parabola if either a or c is missing, because if a or c is zero. Because if either a or c is zero, then there's only one squared term, so we'd get a parabola. The other stuff, D, E, and F determines shifting. Where was the graph shifted around, up or down or left or right? Okay, so I'll leave it to you to figure out why the B is not here. If you can't figure it out, it's not going to hurt you in the long run, but I'll leave it to you to figure that out. All right, so here it says, find the vertex and focus of the parabola. So if I didn't tell you, first of all, that this was a parabola, how would you know? Taking a look at the equation, it's x squared minus 2x plus 4y minus 3 equals 0. There is an x term that's squared, but there's no squared y term. If only one of the variables is squared, it's going to be a parabola. So it's a parabola. Since the x is squared, that means that it's going to open either up or down. And so to find all the stuff, we're going to want to rewrite this in kind of that standard form, x squared equals 4py. And so once again, to do that, we're going to be completing the square. So I'll take x squared minus 2x. We'll leave that on the left side, and then everything else will be on the other side. So we'll have negative 4y plus 3. I've just added everything over to the other side. So now to complete the squaring x, half of negative 2 is 1. 1 squared is 1. We'll add that to both sides. And then factoring, the left side will have x minus 1 squared. And then the right side, that's negative 4y plus 4. And we're going to factor out the negative 4. So we have y minus 1 inside of the parentheses. And that makes it so that it more or less fits that pattern. And so we'll be able to figure out what shift happened, and so where is the vertex. So since it's x minus 1, that means that it had been right shifted. So the vertex's x coordinate will have to be a 1. Y minus 1 means that there was an upshift by 1 unit, so the y coordinate of the vertex is a 1. Okay, and then it's basically x squared equals 4py. And so on this one, the p has to be negative 1. Okay, and so we need to think about, is that negative 1, 0, what is the coordinates of that thing? So once again, a sketch is going to help you with this. The vertex we saw is at the point 1, 1, right? If it's at 1, 1 and this thing opens which way? Well, x minus 1 squared is always positive. Let's take the non-shifted one out. Okay, x squared equals negative 4y. X squared is always positive. Okay, if x squared is always positive, then negative 4y has to always be positive. Negative 4 is negative, so y has to be negative. That means that this thing has to open downward. Okay, if this thing opens downward, then that means that the focus will be below the vertex, and the distance is going to be 1 unit. Right, it's 1 unit below the vertex. So the focus will have the same x coordinate, it'll be 1, but the y coordinate will be 1 less at 0. Okay, So we got the vertex at 1, 1 and the focus at 1, 0. Okay, and again, how we got started was by completing the square so that we could recognize the shape. Okay. All right, so now finding an equation. So for this one, we want to find the equation for this parabola. It has vertex at -3, 5, and the directrix is going to be y equals 2. So once again, a little sketch will help. So the vertex will be at -3, 5. Okay, and then the directrix has to be 2. I feel like we did this one already. Maybe we did do this already. All right, so this is a -3, 5. The directrix is 2. And so this will have to open upward. Right, it's going to open away from the directrix. So it will be x squared equals 4py. The vertex is at an x coordinate of -3, so we'll have x plus 3 squared. The y coordinate was at 5, and so that was upshifted by 5. We'll have y minus 5. And then for the p, I think we did this before, but repetition is a good thing. All right, so the y coordinate for the directrix is going to be 2, so it's a distance of 3 units from the directrix to the vertex. So that was 3 for our p. So x plus 3 squared equals 12, y minus 5. Okay, so there's our equation for the parabola. So this should be more fun, sorry. Here it says complete the square to determine whether this thing is a ellipse, hyperbola, parabola, what is it? If it's, depending on what it is, find all this stuff. If it's an ellipse, find the center, foci, vertices, lengths of the axes. If it is a parabola, find the vertex, focus, and directrix. If it is a hyperbola, find the center, foci, vertices, and asymptotes. So this thing, it turns out that it is a hyperbola actually, because we have the x squared and y squared terms are both here, but they're opposite in sign. Okay, and so that's going to make it so that it's a hyperbola actually. So we'll want the center, foci, vertices, and asymptotes. So we definitely got plenty of work to do here. So where we'll begin is by completing the square to put this thing in the kind of standard form for a hyperbola. So that means that I want to rewrite this so that all the x stuff is together, and then the y stuff is together. And then let me put that -288 onto the other side. Okay, I didn't lose anything, right? X 16x squared minus 96x minus the 9y squared, and then the 288 moved to the other side. Okay, so now let me factor the 16 out of the first two terms. So that will leave us with x squared minus 6x. We'll leave a little spot, a little space. And then minus 9y squared will still be there. Our -288 will still be there. Okay, so we need to add something in here to complete the square in our x's. And so inside the parentheses, we've got that -6. Half of -6 is -3. -3 squared is 9. So I'm going to add in this red 9. Notice when I did that, if I quit right now and multiplied, we'd have 16 times 9, which is 144. So drawing in that red 9 increased the left side by 144. So we're going to add 144 on the right side, not 9. Okay, so that will help. Okay, so now we're ready to start factoring. So we will have 16. And then x minus 3 squared minus 9y squared, and that's equal to -144. Okay, so it's a hyperbola, and so we need to get that right side equal to 1. So let's go ahead and divide all the way through by -144. Okay, so if we're dividing by -144, 16 over 144, that will be a -9. So I'm going to actually switch these two terms so that we can keep the first term positive. So then the first term will be y squared over 16. So we'll have y squared over 16. Okay, 9 goes into 144, 16 times, minus over minus is plus. And then the x term will come next. We'll have minus, and then that will be x minus 3 squared over 9. And then the right side is equal to 1. All right, so all of that completing the square stuff has made it so that we can better recognize what our hyperbola is going to look like. Okay, so we're going to find the center, foci, vertices, and asymptotes. So center first. So the center, we have a horizontal shift of 3, and then the vertical shift, that's just y squared, so that'll be 0. So the center is at 3, 0. We wanted the foci next, okay? For the foci, it's c squared is a squared plus b squared, right? So that's c squared is 25, and so c is 5. All right, so we need to think about that, where the foci are relative to the center, because it's not going to be just like 5, 0 and -5, 0. So at this point, it's a good idea to start thinking about how the picture is going to look. Okay, so I know that the center is at 3, 0, and we need to think about which way is this thing going to open. On this one, the unshifted version of the hyperbola would be y squared over 16 minus x squared over 9 equals 1. Okay, on this one, if x is 0, y would be plus or minus 4. So if x is 0, y would be plus or minus 4. So this one would have two y-intercepts if it were unshifted, right? And so from our center of 3, 0, we'll go up and down by 4 units. Okay, so roughly it's going to look like that. Okay, we'll make a better looking picture later. Okay, so the foci will have to have the same x coordinate, that's 3, and they will be plus the center plus or minus 5. So that will be foci 3, and then the y coordinate here was 0, so it will be 3, 5, and 3, -5. Okay, and then vertices were at 3, 4, and 3, -4. Almost there. Last thing to do would be to get the asymptotes. So let's do that. So the asymptotes will have to pass through the center, which is 3, 0. And then we can figure out what their slopes are. It's been a little while since we did the slopes on these asymptotes, but let's think about it. So for the asymptote slopes, that will be the change in y over the change in x. So taking a look at our equation, the number underneath y is a 16. Square root of 16 is 4. And then for x, underneath x is 9. Square root of 9 is 3. So the two asymptote slopes will be plus and minus 4/3. And then they will have to pass through the points 3, 0. Okay, so let's get those. So y will equal -4/3 x plus b. Okay, I know I'm going to do the -4/3 one first. So when x is 3, we should have a y coordinate of 0. So we'll use that to help us solve for b. So b will have to be 4. So then one asymptote will be y equals negative 4/3 x plus 4. Then let's get the other one. Y will equal 4/3 x plus b. Our y coordinate will be 0, and our x coordinate will be 3. And so b will be negative 4. So we'll have y equals 4/3 x minus 4. Okay, so that will be our two asymptotes. Okay, so that was kind of a lengthy example, but we did a lot of stuff in there. We completed the square to put the equation in the identifiable form. We were able to figure out where the center was, and then from there we had to calculate where the foci would be, where the vertices would be, and then finally we had to find the equations for the two asymptotes. All right, so that does it for this part of our work on conic sections. We just have a little bit more to do, and that will occur in our next video. In the meantime, let me know if you have any questions, and have a great day.